We are a group of two, myself Likhit and my friend Tejas from CSCI 5922 Neural Net and Deep Learning class. We are here to present our project idea SwarAI, an AI powered demixing of Indian songs. Most of the AI models for music source separations are made from Western music dataset, but Indian music is much more complex and it has unique styles like gamakas and tabla beats. Our plan is to build a system named Swar AI that understands Indian music much better and can separate vocals and instruments in a much more accurate and efficient way than the traditional models present out there.
So coming to current solutions, there are multiple tools like MUS DB18, Splitter and models like HTDMux and TaskNet which are already good for this particular task. But the dataset to train and evaluate these models was mostly on Western songs. So they don't handle Indian instruments like the tampura and the tabla well. They also miss fine vocal details which are common in Indian classical or Bollywood music. To address this, we have manually created a small but a high quality data set which has 50 songs, and those 50 songs we have manually separated into vocals and instruments. This dataset consists of 37 Bollywood songs and 13 classical songs. Now we have tested these on the existing models, that is we ran the HTDMux to Demix, and we have collected some base parameters for evaluation. Now fine tuning, we have used two different techniques which is LoRa and partial freezing.
So, coming to the evaluation strategies, so we use three methods: signal to distortion ratio, which measures how much the separated audio file resembles the true source; signal to interference ratio, which tells how well the model removes the unwanted sources like background noises and instruments; third, signal to artifacts ratio, which measures the amount of artificial noise or distortion that has been introduced during the separation of these music files. So, coming to the LoRa based fine tuning method, we can see that there is a degradation of the standard base parameters which performed well in HTDMux model, but in LoRa model it didn't perform well. But there could be possible reasons. So some of them are: we fine-tuned using the 30 seconds chunk to capture more musical context, but this may have overloaded the model without enough data to record its different variations. The selection of layers where LoRa was likely applied contained valuable information and some of it might have been lost. Due to the time and resource constraint, excessive hyperparameter tuning was not possible in this project phase.
So coming to partial layer freezing results, we can see here that the average SDR of vocals and instruments have improved, but the average SDR for instruments has improved significantly. It's the same case with SAR. But with the average SIR, there is already infinite score, which means that it is already perfectly separated. So there's no change in that. But overall, there is an improvement. So in this project, we explained different fine-tuning strategies to adapt HTD mix for Indian music source separation. While LoRa did not yield significant improvements, it can also be due to our selection of which layer to apply LoRa. So if we had more time, we could have explored multiple options as well as played around with the hyperparameters. But partial layer freezing the encoders and decoder layers did show a significant improvement. Thank you. If you have any questions, we'll be happy to answer them.